Good morning. Today we moved outside at the sustainability team stand, and I'm very glad I am going to introduce Peter Hanap. Good morning. Who is going to explain us what is going on in this stand and the overall project we are watching in this stand. So thank you. And
Thank you, Milena. So welcome to the stand of the sustainability of the Sony Computer Science Laboratories. So it's important to keep in mind the topic of sustainability. We'll be showing robots here, but our ultimate goal is really about sustainability. And we started working on sustainability in agriculture because it's a fantastic field. There are really many topics that you can address in this field. And one of the things that we got interested in is to work with small vegetable farms. Why? Because, well, they're a really interesting environment to think about how technology could help sustainable farming. There are also many of these small farms are experimenting with new ways of producing vegetables. So there's a lot of experimentation going on, a lot of interesting people thinking about how to produce food, and being able to exchange with these people on how technology can be helpful is very interesting. Now we'll look at some of the tools that we make here. Of course, the question is larger than just producing food. So there are other interesting questions like how do you distribute food, like the logistics? How do you organize where you put farms? Like for us, it'd be interesting, I think, to put farms close to the city to produce locally. So all these are very interesting questions that touches both on technological issues and societal issues. So it makes it a very rich topic. So today we'll go at the Maker Fair, so we'll look more at some of the technologies. And one of the things that we've been working on is robots to help these farmers with physical tasks. Many of these small farms, organic farms, still use a lot of manual work, which is quite physical. And so can robots be useful there? It's still an open question, and we started working on some ideas. And Doug, my colleague, will show one of the robots that we've been working on, which is designed specifically for weeding.
okay, so maybe shall we move in? Oh, hello, hello, Doug.
Sorry.
Okay, so can you just explain? Okay, we are here with Douglas Boari, and thank you for being here. And yeah, so what is going on here?
Okay, so this is the ROMI project. ROMI stands for Robotics for Microfarms. So it's a European-funded project, part of the H2020 program that was won by the sustainability team at Sony Computer Science Labs in Paris. And the aim, as Peter said, is really to look at how we can integrate robotics into small-scale agriculture. And because it's a Horizon 2020 project, at the end of the project, everything we've done from the designs for the robot, for the hardware, the software is all going to be open source. It's all going to be freely available and downloadable. So if you're that kind of person, you could build one yourself. So it's absolutely perfect for makers.
Okay, and who are the addressee of the project?
It's an interesting question. So alongside the large-scale agriculture that we see every day, where they're planting a single crop and you have miles and miles and miles upon miles of corn, for example, there's a large number now, it's ever-growing number of small organic microfarms. And these organic microfarms are actually very, very productive because they co-plant plants. So that is, they put a lot more plants in a very small space and optimize their space. So let me give you an example. So for example, if you plant a cabbage and around the cabbage, you plant a lettuce, okay? The lettuce grows a lot faster than the cabbage. So by the time the cabbage has grown, you've harvested your lettuce and you've got two crops in the same space. So actually these farms, which are generally pretty small, 0.5 to sort of 5 hectares in size, can actually be very, very productive. But one of the problems that they've got is if they're trying to stay organic, they can't use herbicides. So as Peter said, that's very manually intensive labor. It's very costly. It's a lot of hard work. And so it's actually very difficult for them to stay economically viable. So generally agricultural equipment is very expensive. You're talking hundreds of thousands of euros, you know. So this is where the Romy rover comes in. So the build cost on this robot at the moment is around 7,000 euros. So it's good for the farmer, it's good for the consumer, and it's generally good for sustainable agriculture.
And can we see how it works?
Yeah, sure. Let's make
And details, yeah, it's a mega fair. So probably we can.
Yeah.
We have to.
Most of the components we've got in here are all available off the shelf. So we are using Arduinos, we're using Raspberry Pis, we're using controllers for the wheels that you can just buy anywhere off the shelf. So really, apart from the frame, pretty much everything you can just buy somewhere. Easy enough. I don't want to say names of stores. We have a camera at the top. And what happens is every time the robot moves, can I just show you this image here? Every time the camera moves, we take an image. We then use some artificial intelligence to create a mask so we know exactly where the plants are. And then in between the plants, we plot a route. And we pass over the route. You probably can't see it very well from here, with a rotating hoe. So it's a system that goes in between the plants and will just remove the weeds. And if you go over once or twice a week, it's enough to stop the weeds growing. On the physical side, the rover's constructed to be adjustable. So it fits a standard weeding bed of 80 centimeters to 120, 150 centimeters. And it can be adjusted depending on what yeah, exactly. Technology-wise, as I said, everything's off the shelf. So we have an X-Carve CNC here. Now, this is the sort of component that you would normally find inside a 3D printer or something like that. Again, this is a very maker's kind of friendly tool. And we've repurposed it by fitting the rotating tool on. It's a very simple XYZ mechanism. And once we've taken the photo and we've planned the route, we just move it around over the tools. We have a number of controllers on board. As I said, we're using Arduinos, we're using Raspberry Pis, the things that people love. The main control is done with the Raspberry Pi. Every part of the rover generally has its own simple control system. We've tried to make everything as simple as possible. We have wheelchair motors at the back. These are really, really simple. The only thing we've done is to place encoders on the inside so we can see the rotation of the wheel, so we know how far the robot's moved. Really powerful, actually, really, really surprisingly powerful. We have another Arduino controlling the CNC. So again, this is just all off-the-shelf software. And finally, on the front, we have some stepper motors for controlling the front of the wheels. And the navigation on the robot is completely autonomous. So we started out with, this is a little bit of the evolution of the robot here. So we started out with some wooden frames just to try to get things, right, the control systems. And then we eventually progressed through aluminium to a larger robot that we used rails. Obviously, there's a cost involved in rails and it's more work, and farmers don't need any more work. This is what we're trying to avoid. So we've put in a system now that uses computer vision, and it will follow the plants. So it's completely autonomous. You can set it off at the beginning of a bed. It will do 50, 60, 100 meters, do the whole bed completely autonomously.
Okay, so did you already try it on a...
Yeah, in fact, we've designed it and we've been working with farmers throughout the whole process because, one of the issues that you can have if you design something like this in a lab is you take it to the farm and then you get to the farm and there's things that don't work for the farmer. So we've tried to work with the farmers to make sure that everything is actually useful, and it is being used at some nurseries in Paris.
Okay, so because I was thinking about usability for farmers. And,
it's an interesting question. Like I said, we've been talking with them all along. So they've actually come up with suggestions for the frame. They've helped us with the wheels, giving us ideas on what would work best. And it's been a really good collaboration.
Yeah, thank you.
Thank you
So
thank you.
So I think now we are moving to the other part of the project, and we will meet Nabil, who's waiting for us.
Hi.
Good morning.
Good morning.
And so, yeah, just explain what we have here.
This is the plant imager.
Yeah.
It's a tool made for biologists in order to perform phenotyping.
Okay.
Phenotyping is like studying the external traits of organism, and in our case, plants or crops.
Okay. And so, how does the device works?
Okay. For example, I can take a simple example. In some cases, biologists are interested in tracking the growth of the plant over the time. So, in order to do that, they need a 3D model of the plant so they can get the volume and tracking the difference. So, to do that, we have this device is like a 3D scanner. So as you can see, the small robot will take the plant and put it in the center of the area. And here, I don't know. And here we have a simple camera. Yes, thank you. We have a simple camera that will turn around the pot and will take many pictures of this plant. These pictures will serve to run a software where we can apply some algorithms based on computer vision and machine learning in order to get the 3D model. And after that, the biologist will have like a virtual model of the plant that can be easily studied in the laboratory.
So, can we just have a demonstration of the work? Yeah.
David will run.
Oh, maybe.
So, as you see, the setup is very simple because the robot will follow the green line here, and will detect automatically where to stop and take the pot. Here the robot will turn and will try to put the pot in the center of the scanner.
And so now we are watching at the scanner working.
Yes. As you see, the camera will turn around the plant and will take all the pictures needed to reconstruct the 3D model. And you can notice that this camera is a simple one. It is not a 3D camera. The magic will happen with the software by reconstructing the 3D. And so all these components and elements can be bought in the market. So it's made with very cheap elements. And we had also many students that worked on the project, and that's it.
And can you just underline why all this is so important?
Yes, it's so important because actually the regular scanners are very expensive, and we made this plant imager to be affordable for small laboratories and small organizations to access to this technology.
Okay, thank you.
You're welcome.
Thank you. So now I would like to invite all the team to join me in the center. So this is okay. And I would like to, oh, here we are, yeah. I would like to ask Peter, what are the further development of this project, or maybe other ideas and other projects you are working on as a team?
Well, so today, I mean, we had a quick glimpse of the stuff that we are doing, and I would say, like, if you're a maker, if you're a farmer, if you're a researcher, and you saw things that you like, please contact us, because we really want to make this project as open as possible and as useful as possible. So we invite contributions from everyone. I mean, we're a small team. We will try to integrate, new ideas. The idea is to have indeed a number of tools and devices that can really be useful for farmers and sustainable farming. So I would say, yeah, anyone who's interesting, just come and contact us, and we'll work it out.
Okay, so thank you, Peter, and thank you to all of you. And so we are now moving to the next interview.